So we are doing miscellaneous of chapter determinants. First question is prove that determinant this is independent of theta. It means if we expand this determinant, the answer that we'll get will be independent of theta. There will not be any term of theta. So let us expand this. First of all, writing this x, then this sine theta with change in sign, and then this cos theta as it is. Hiding this x by row and then column, I'll get minus x square minus 1. Hiding this sine theta by row and column, I'll get minus x sine theta minus cos theta. Hiding this cos theta by column and row, I'll get minus sine theta plus x cos theta. Okay, minus x cos theta, and the negative means plus x cos theta. Multiplying minus x cube minus x plus x sine square theta, minus sine into minus cos will make plus sine cos. Cos into minus sine is minus sine cos. Cos into x cos is x cos square. Now these terms will cancel each other, and then x sine square theta plus x cos square theta, I'll take x common from these two terms, and then I'll get sine square theta plus cos square theta. Now sine square plus cos square is 1, so 1 into x is x. Remaining these terms will be written as it is, and this x will cancel this x, and the answer is minus x cube, which is independent of theta. That is, there is no theta term here. So proved. Okay. Question number 2. Without expanding, that is with properties we have to do this question. Prove that this determinant is equal to this determinant. So it's a simple question. What we'll do, first of all, we'll multiply the first row by a, this whole row by a. While doing so, we have to divide outside by a. Similarly, multiply this whole row by b, and we'll divide outside by b, and this term multiply by c, this whole row, and divide by c. So now you'll get ABC, 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 that you can later on take outside common, and then you'll get 1 1 1 that you need to prove here. Okay, so the operations are row 1 becomes a into row 1, row 2 becomes b into row 2, row 3 becomes c into row 3, and dividing outside by ABC. Now as I said, this ABC will be taken common from this column 3. Outside it will go, and these will cancel each other, ABC and ABC. And now we have this whole thing, a square, b square, c square, a cube, b cube, c cube, and 1 1 1. But what we need to prove is that this 1 1 1 should be here. In the second column we should have a square, b square, c square, and in the third column we should have a cube, b cube, c cube. So now what we are going to do, first of all, we'll do column 1 interchanged by column 3. So it means this column will be written here and this column will be written here, and on interchanging the columns or rows, always the sign of the determinant gets changed. So now I'll put a negative in front of determinant, and you can see this column I've written here and this column I've written here in place of column 3. Now still we are one step away from our answer. We need a square, b square, c square here, and a cube, b cube, c cube here. So now I'll interchange c2 with c3, as you can see, and again on interchanging, one more negative I have to put in front of determinant, which will cancel this negative, and now it will be positive. Okay, so already one negative was there, one more negative will come because we are interchanging c2 with c3, so it will become positive. In the second column, a square, b square, c square will come, and similarly in the column 3, a cube, b cube, c cube will appear. So this is our final answer. Question number 3. Evaluate. So nowhere it is written that whether we have to only use properties. So we can simply expand this determinant. So I'm doing this expansion along column 3. So we have to choose the easiest column. Here there is 1 0. So expanding along column 3 will be easier. First of all, I wrote minus sine alpha. Then 0 I didn't write because 0 into anything will be 0. The next term, there is cos alpha. Okay, sign convention, plus minus plus means no change in sign, and no change in sign. So 0 we haven't written, so that also need not to be done, -0. Okay, so this column I have hidden by this line, and now minus sine alpha. On hiding this with row, we'll get minus sine beta into this. So it will become minus sine alpha sine square beta, as you can see here. And then cos beta into this will give you cos square beta sine alpha, negative cos square beta sine alpha. So this is negative. Then for this 0 I haven't done any calculation. So for this cos alpha now, hiding it with row, I'll get cos alpha cos square beta minus cos alpha sine beta into sine beta. So it will be cos alpha sine square beta of negative. On multiplying this, we'll get a negative term, but then we have to change the sign, so it will become positive only. Right? Okay. Now further, here we can take minus sine alpha common. So on taking minus sine alpha common, here there will be sine square beta and here cos square beta, and since I have taken negative outside, it means plus sine square beta plus cos square beta will be inside. Similarly, from here taking cos square alpha common, so we'll have cos square alpha, and inside we have cos square beta plus sine square beta. This term will become 1, this term will become 1, right? And now, since already a negative was outside and from inside also I have taken a negative, outside it will be positive, so sine square alpha plus cos square alpha will be 1. Okay, I hope it is clear. Already minus sine alpha was there. I took minus sine alpha from inside, so minus sine alpha into minus sine alpha will be sine square alpha, right? Inside sine square beta plus cos square beta, which will become 1. Taking cos alpha common from here, cos square alpha outside, inside there will be cos square beta plus sine square beta, that will be 1. 1 into cos square alpha is cos square alpha, 1 into sine square alpha is sine square alpha, and on summing them we'll get 1. Sine square plus cos square is 1, right? So question number 4. If A, B, C are real numbers and determinant this is 0, show that either A plus B plus C is 0 or A is equal to B is equal to C. So now this I'll solve with properties. You see, if I add in row 1, row 2 and row 3, what will happen? In row 1 I am adding row 2 and row 3. See, B plus B will become 2B, C plus C will become 2C, A plus A will become 2A plus B plus C. Similarly, this element on adding these two elements will become 2 bracket A plus B plus C, and same is with this element also. Then we can take 2A plus B plus C common outside, and this is how we'll get A plus B plus C. Okay, so the planning goes like this, adding row 2 and row 3 in row 1. So as I explained earlier, it will become 2A plus B plus C in the whole column, whole row 1. And now taking 2A plus B plus C common, here I'll get 1, 1, 1. Okay, now once we get 1, 1, 1 from exercise 4.2, we have learned we have to make these 1, this one and this one 0. So to make this 0, what I'll do, column 2 minus column 1, and similarly column 3 minus column 1. So column 2 minus column 1 means 1 minus 1 0, A plus B minus C plus A. So A plus B minus C plus A means A will be cancelled with A and we'll be left with B minus C only. Once I'll do it for you, A plus B minus C plus A. So brackets are must. So A cancelled by A, and then we are left with B minus C. Similarly, you can subtract these to get C minus A. this minus this, you'll get B minus A, and this minus this, you'll get C minus B. So once you get this, now we can expand it with row 1. I'll just write 1 and hiding it with column and row, just multiplying these two elements, B into C, that is BC. I'll write it here to explain you BC. Then B into minus B is minus B square. Then minus C square. And then plus CB or plus BC. So this is how we get 2BC minus B square minus C square here. See? Okay. Now similarly we'll multiply this. So negative sign multiplying these elements. BC minus BA. BC minus BA. Okay. BC minus BA. And then BC minus BA, then minus AC plus A square, minus AC plus A square. Okay, BC minus BA minus AC plus A square. And now since negative outside, therefore the signs of all these elements will change. So minus BC plus BA plus AC minus A square, right? Square is here, not here. So already I'm still having this problem with the writing software. So writing is like this. Okay. So now simply what we can see here is 2BC minus BC is plus BC, then BA is there, then CA is there, minus A square minus B square minus C square, everything is here only. Now since this whole determinant is equal to 0, so we can say either this thing is 0, A plus B plus C is 0, because if the product of two numbers is 0, then either first number is 0 or second number is 0 or both may be 0. So either A plus B plus C is 0, right, or this whole thing is 0. So first condition is either A plus B plus C is 0, and this one I will solve. So to solve this equation further, what I am going to do is I'll multiply this term with 2 and take negative common outside. Okay. So on multiplying this equation both sides by 2 and taking negative common from inside, what I'll get? I'll get plus A square into 2, right? Plus B square into 2 and plus C square into 2. Okay. And here minus 2AB minus 2BC minus 2AC, right? I have multiplied the equation by 2, so I'll get 2AB, 2BC, 2CA minus 2A square minus 2B square minus 2C square, and then taking negative outside, it means it will be 2A square plus 2B square plus 2C square minus 2AB minus 2BC minus 2CA, right? Because I've taken negative outside, and 0 into 2 is 0 only. Now 2A square, I can write it as A square plus A square. 2A square, I can write it as A square plus A square. 2B square, I can write it as B square plus B square. Two C square, I can write it as C square plus C square. So no problem up to this point. Okay. And already we have minus 2AB minus 2AB minus 2BC and minus 2CA. Okay, now what will happen? This is CA. So A square plus B square, A square plus B square minus 2AB can be written as A minus B whole square. Then A square plus C square minus 2AC can be written as A minus C whole square or C minus A whole square, both are same. And B square plus C square minus 2BC can be written as B minus C whole square. and that is equal to 0. So this can be equal to 0 only if A is equal to B. So if A is equal to B, only then this whole thing can become 0, and B is equal to C, only then this whole thing can become 0, and C is equal to A, only then this whole thing can become 0. Otherwise, there is no possibility then that this whole thing can become 0. Why? Because square terms can never be negative. So if none of these terms is negative, then how can the sum become 0? So there is only one option. These all must be 0 only, because square of a term can be either 0 or positive. So if these terms are positive, then they can't be 0. So it means these all three terms must be 0. So 0 plus 0 plus 0 will become 0. It means A should be equal to B equal to C, right? So the condition we got is A is equal to B is equal to C. Okay? Or A plus B plus C is equal to 0. Question number 5. Solve the equation. That is, we need to find the value of x. And this kind of questions we have already done in exercise 4.2. Now what I'll do, in row 1, I'll add row 2 and row 3. So x plus a plus x plus x will become 3x plus a. Similarly 3x plus a, similarly here 3x plus a we'll get. Now we can take 3x plus a common, and now we'll get 3 ones here. Once we get 3 1, we can make this 0 by column 2 minus column 1. Make this 0 by column 3 minus column 1. So 1 minus 1 is 0. X plus a minus x is a. X minus x is 0. 1 minus 1 is 0. X minus x is 0. And x plus a minus x is a. Okay. Now I can expand with row 1. So because two zeros are there, so 1 hiding it with column and row, I'll get a square minus 0, that is a square, right? So I have 3x plus a into a square, that is equal to 0. So from here, a I'll send towards 0, so it will become 0 itself. X will be minus a by 3, so this is our answer. Okay. Question number 6. So this whole thing, we need to prove it equal to 4a square, b square, c square. So what to do? First of all, from column first, I'll take a common, you can see. Column 2, I can take b common, and column 3, I can take c common. So from here, I'll take a common. A, the remaining terms I'm telling you, a plus b and b. And if I take b common, C, B, B plus C. If I take C common, A plus C, A, C will be the remaining terms. A, B, C outside. Okay. Now once we get this determinant, what we can do? Row 2 minus row 1. Row 2 minus row 1. So if I subtract row 1 from row 2, what I'll get? A plus B minus A will be B. B minus C I'll get, and a minus a plus c, that is minus c. Similarly, row 3 minus row 1. B minus a I'll get, b plus c minus c is b, and c minus a plus c is minus a. Okay. Further, in row 2 I'll add row 1. So here we'll get b plus c, b plus a. Here I'll get b, same term as this term. Then minus c plus a I'll get a, same term as this term. Okay. Now in row 3 I'll add row 2, and what will happen now? Minus a plus a will cancel out, and I'll get 2b in row 3. B plus b will be 2b, and minus a plus a will be 0. So in this row 3, I can take 2b outside. So once again, you see the operations what we have applied. First of all, row 2 minus row 1. Okay, so on doing row 2 minus row 1, I got b, b minus c, minus c. Row 3 minus row 1, b minus a, b minus a. Okay, because c minus a minus c will be minus a. Once this is done, in row 2 we'll add row 1. So now we'll get here b plus a, b minus c plus c will be b, and minus c plus a will be a. And now last, in row 3 I can add row 2. Okay, so cancelling a by a will get 2b, then 2b again, and minus a plus a will get 0. So this is the set of operations that we have applied, and now we can take 2b outside, and there are other methods also you can do by those methods as well. Okay, so once you get 1 1 0, I'll make a 0 here also. So column 2 minus column 1, 1 minus 1 will be 0, b minus a minus b, b minus a minus b will be minus a, and c minus a. Okay, and now we have this one here, we can expand through this row. So only for this one I have to solve. So hiding this with column and row, column and row. So this into this, c minus a into a, that is ca minus a square, minus a into a, that is plus a square, and minus a into c. Why I am saying minus 2 times? Because when we multiply this, then we have to put a negative also outside. So minus a into a plus c means minus plus a plus c, and that will be a square plus ac only. Okay, then we can cancel these terms, and ac plus ac is 2ac. So bit of a tricky question, you should memorize these operations. Okay, other methods are also there, you can do by those methods as well. Now, question number 7 just up to question number 9 we'll do in this video, and then for other questions we'll make another video. In question 7, what we need to do is find AB inverse. Okay, so to find AB inverse, what I'll do, I'll simply write AB inverse as B inverse, A inverse. Already I know what is A inverse, so simply if I can find what is B inverse, I can multiply B inverse into A inverse, and then I'll get AB inverse. So how to find B inverse? Already in last 2-3 videos we have learned how to find inverse of a matrix. First of all, we'll find the determinant, and through column 1 I am finding the determinant. First of all, I wrote 1, hiding this 1 by column and row, so I'll get 3 minus 0, that is 3. Now changing the sign of this element, that is plus 1, hiding this with row, so 2 1s are 2, minus 4, that is minus 2 only, minus 2 into 1 will be minus 2, and this 0, simply I have just written 0 because 0 into anything will be 0. Okay, now cofactors we'll find. Okay, so you must be knowing that this element, this cofactor, this cofactor, this cofactor, and this one we have to write with change in sign. After changing the sign of the number, minor, we'll write them here. So already I've changed the sign. Okay, now if I hide this 1 with row and column, I'll get 3 minus 0, that is 3. Then hiding this 2, row and column, I'll get minus 1, but by changing the sign, after changing the sign, I'll write it as 1. Then hiding this element, I'll get 2 minus 0, that is 2. Adding this element with column and row, I'll get 2 minus 4, that is minus 2, but I changed the sign, right? Then this central term, hiding this with row and column, I'll get 1 1s are 1, minus 0, that is 1. And then hiding this 0 by row and column, I'll get minus 2 minus 0, that is minus 2, but then we have to change the sign as well. Okay, then the 0 hiding with column and row, I'll get 0 plus 6. Okay, hiding this minus 2 by row and column, I'll get 0 minus 2. 0 minus 2 means minus 2, but for these 4 elements we have to change the sign, so it will become 2. Hiding this 1 by column and row, I'll get 3 plus 2, that is 5. So cofactors are done. I have done it very quickly, swiftly, because already we have done this in previous exercises, previous videos. Now adjoint B, just write this first row as first column, second row as second column, third row as third column, and we get a adjoint B. And B inverse is 1 upon determinant A. In this case, determinant A is 1. So 1 upon 1 into adjoint B. So simply it will be equal to adjoint B only. If the determinant is 1, then B inverse is equal to adjoint B. Yes, now B inverse into A inverse. This is B inverse, and A inverse is already given in the question itself. And now simply we'll multiply row with column. So 3 3s are 9, minus 30 plus 30. Next column, minus 3 plus 12 minus 12. Okay. Next column, 3 minus 10 plus 12. Right. So this is how we multiplied it with first row with all the columns. Now it's the turn of second row. 3 minus 15 plus 10. Minus 1, 6 minus 4. Then 1 minus 5 plus 4. Okay. So second row also done. And now third row. So 6 minus 30 plus 25. Minus 2, 12 minus 10. And 2 minus 10 plus 10. And after adding, subtracting, we'll get B inverse A inverse, which is equal to bracket AB inverse. So now we'll do question number 8. So question number 8, matrix A is given and we have to verify that adjoint A inverse is equal to adjoint A inverse. So remember this thing, that this question may also appear for 1 mark. What is adjoint A inverse equal to? So the answer is adjoint bracket A inverse. You can understand the difference, I guess. First of all, here the adjoint A need to be calculated and then its inverse we'll find. And here, first of all, A inverse will be calculated, then its adjoint we have to find. So this is the part 1, and in the part 2 you will show that the inverse of A inverse is actually A. Okay, so okay, we'll see. So matrix A is here already given. First of all, we'll find determinant. So from any side, if you find it is the same, so I'll choose row 1. So first I wrote 1, then plus 2 by changing the sign, and this one, hiding this 1 by row and column, I'll get 15 minus 1, that is 14. Hiding this 2 by row and column, I'll get minus 10 minus 1, that is minus 11. Hiding this 1 by column and row, I'll get minus 2 minus 3, that is minus 5. And now 14 and minus 11 into 2 is minus 22 and minus 5. And on calculating, we'll get minus 13 as determinant A. Now comes cofactor. So while again I'll tell you, while calculating cofactors, these signs we change, right? So already here the signs have been changed. So for 1, if I hide 1 by column and row, I'll get 15 minus 1, that is 14. Hiding this element by row and column, I'll get minus 10 minus 1, that is minus 11, but the signs have been changed. This element by row and column, minus 2 minus 3, that is minus 5. This element by column and row, minus 10 minus 1, that is minus 11, but the sign has been changed. This 3, 5 minus 1, 4. This element, 1 plus 2, 3, sign has been changed. And now this element. So why to repeat all these things again? You will get cofactors like this. And adjoint A, first row will become first column, second row will become second column, third row will become third column. This is our adjoint A. So you know that we require adjoint A, right? Also we require A inverse. So a lot of things we have to compute here. So A inverse is 1 upon determinant A adjoint A. So determinant A is minus 13. A inverse is 1 upon minus 13 into adjoint A. So this is our A inverse. And sending this negative inside will make things easy. Multiplying this negative with all the terms. Right. So this is the preparation we have done to do our part 1 and part 2. So what is part 1? Part 1, I'll repeat it again. We have to find the inverse of adjoint A, first thing. And then secondly, at the RHS, we have to find adjoint of A inverse. So finding inverse of adjoint A and finding adjoint of A inverse. So let us see. So first of all, I'm finding inverse of adjoint A. So what will be the formula? The formula will be 1 upon determinant of the matrix for which you want to find the inverse. So 1 upon determinant of adjoint A, right, into adjoint of that matrix, and that matrix is adjoint A. I repeat myself, for whichever matrix you want to find the inverse, first of all find the determinant of that matrix and then apply this formula 1 upon determinant of that matrix into adjoint of that matrix, and that matrix in this case is adjoint A itself, right? So first of all, I'll calculate that determinant by the row, first row. So writing this 14, changing the sign of 11, minus 11, and then minus 5 as it is. So hiding this 14 by column and row, I'll get minus 4, minus 9. Okay, so this is minus 4, minus 9. Then hiding this 11 by row and column, I'll get minus 11, minus 15. Okay, and then hiding this minus 5 by row and column, I'll get minus 33 plus 20. Okay, so minus 13, minus 26, minus 13, multiplying 14 by 13, 26 by 11, and 13 by 5. And adding them up, I'll get 169. Now I need to find its adjoint also, for which first of all I need to find the cofactors. So in short version I am doing here. Okay, so first cofactor will be, I'll first find minus, then change the sign. Hiding this 14 by row and column, I'll get minus 4, minus 9, that is minus 13. Minor 1, 1. Hiding this 11 by row and column, I'll get minus 11, minus 15, that is minus 26. So if you change the sign of this element, directly you'll get cofactor. I'll do it later. Hiding this element by row and column, minus 33 plus 20 will be minus 30. So I hope this is clear. Hiding this 11 by column and row, I'll get minus 11, minus 15, that is minus 26. Again, this is minor only, minor 2, 1. Hiding this element by row and column, I will get minus 14, minus 25, that is minus 39. And now hiding this element by row and column, I will get 14 into minus 3, that is minus 42, and plus 55. So it will be minus 13 again. Isn't it? Plus 13, okay, plus 13. Again we'll see minus 42 plus 55. So it will be 13. Later on we'll change the sign. And now this element, minus 33 plus 20, that is minus 13. Hiding this element by row and column, I'll get minus 42 plus 55. So again 13. And hiding this element now by column and row, 14 fours are 56 minus 121. Okay, so 121 and 56 we have to subtract. So we'll get 11 minus 6, 5, 11 minus 5, 6, 65, minus 65. Okay, now change the sign of these elements. You already know the pattern in which we change the sign. It will be negative, right? And now first row as first column, second row as second column, third row as third column, and you will get adjoint of adjoint A. Okay, so inverse of adjoint A is 1 upon determinant adjoint A and then adjoint of adjoint A. So instead of adjoint A, you can name it as C also. It will be simpler, or B, whatever. Okay, but it will remain the same. The calculations will remain the same. Only you'll get it easier to write and understand. Okay, we are just finding inverse of B, so it is 1 upon determinant B adjoint B. And what is that B? Adjoint A only, right? Now taking 13 common from out inside, and 13 upon 169 will be 1 upon 13, and inside this term you will get. Okay, so what we have done here, adjoint A inverse we have calculated. And now what we need to do, we need to find A inverse. A inverse we have already computed. This was the inverse, right? So its adjoint we have to find. So this is our question now. So this is our A inverse, 1 upon 13, this whole thing, sending this 1 upon 13 inside, and now tedious work we have to do, right? So how to calculate? Hiding this element, we'll get minus 4 by 39 and minus 9 by 39. Hiding this element, we'll get minus 4 by 169 minus 9 by 169. Similarly, hiding this element, we'll get minus 11 by 169 minus 15 by 169, that you can see. And the sign change also for these 4 elements, 1, 2, 3, 4, right? Don't forget that. And hiding this element by row and column, we'll get minus 33 by 169 and plus 20 by 169. Let us see, right? Similarly, we'll hide this by column and row, we'll get minus 11 by 169 minus 15 by 169. See, sign change. Then this element, column row, minus 14 by 169 minus 25 by 169. See, and then next, hiding this by row and column, 14 threes are minus 42 by 169 and this one plus 55 by 169. This one with change in sign, right? And now last one, hiding this element by column and row, minus 33 by 169 and plus 20 by 169. And similarly, this element I'll hide by row and column. So minus 42 by 169 plus 55 by 169. And the last one, this one, 14 fours are minus plus 56 it will be. And then minus 121 by 169, 56 minus 121 by 169. Since the denominators are same, it's easy to calculate, and then we can take 169 outside. 13 also we can take outside. So simply we'll get adjoint A inverse, which is equal to inverse of adjoint A. So calculation is the skill they are testing here, right? I haven't seen this question ever appear in any CBSE exam, but still you should do this to check whether you are good at calculation or not. The next thing, what is the next part? Let us see. Such a long question it is. Second part, A inverse inverse we need to find. So again we'll find inverse of A inverse. Okay. So A inverse is this. We already have seen this. Now I'll find its determinant. Right. So simply cube of 1 by 13. Reason. What is the reason behind this? Anybody knows? Because if I send this 1 by 13 inside, so it will be in the first row, second row, third row, all the rows. Then changing it to determinant. Now try to take 1 by 13 outside common. So first you have to take it from row 1, then row 2, then row 3. Because in matrices, when we take common, it is from the whole matrix. But when in determinant we take common, it is from one row only, right? So why first, if we send this 1 by 13 inside, it will get multiplied with all these terms 1 by 13, right? And when we try to find its determinant, first we'll think, okay, we should take this upon 13, that is the 13 in the denominator common. So first we'll take from row 1, then second row, then third row. So there will be 3 1 by 13. Got it? Okay. Second explanation is this, that Ka determinant is equal to, already we have learned, K raised to power N determinant A, isn't it? So this we have already learned in previous videos. That's why also N is the order of A. That is why we can simply put 1 by 13 raised to power 3. Now we have solved this determinant. I am not explaining again and again. This is minus 169 by 13 cube, which will be minus 1 by 13. Adjoint. Now adjoint also we need to find for this. So same method. So second part I am skipping. Try to do it by yourself. Question number 9. Last question of this video. Evaluate. What we'll do? Adding row 1, row 2, row 3. So in the top row we'll get 2x plus y, 2x plus y, 2x plus y. Taking this 2x plus y common, we'll get 1 1 1. Now we'll make this 0 by subtracting column 1 from column 2, and this also by subtracting column 1. So here we'll get 1 minus 1 0, x plus y minus y is x minus y is minus y, x minus y is minus y, x minus y again, y minus x minus y is minus x, and then expanding along this one, minus x square, and then minus plus y into x, see, minus x square, and then minus y into x minus y. Okay, x minus y, and then simply solve it. So this is x square plus y square minus yx once you take negative common, and now a plus b, a square plus b square minus ab is a cube plus b cube. So you'll get your answer. Okay, so some questions I have done very swiftly because I know that your basics are clear. So if you are unable to understand some of the questions, then you can go back, watch some more videos, basic videos, then come back, then you will be able to understand. So we'll see remaining questions in the next video.